Hi, this is Mike at Cleveland Aircraft Tool, and we're going to talk about some 3M products. We have the 3M wheels and we have the 3M hand pad. So real quick, we're going to do a quick overview of these things with our general recommendation, then we're going to go into proper use, common mistakes, and why we carry what we carry. So if you're just interested in which one to buy, if you're only going to buy one wheel, it's our part number 3MW7A6. And then you will need some hand pads, which are 3MP47. So the difference in the wheels, obviously you have 6-inch wheels and a 2-inch wheel and 1-inch wheels. So the 6-inch wheels work great on a bench grinder. Let me pull up a picture of that. And the bench grinder has, or the buffer that I'm showing here has no guards on it. You can also use a grinder with removable guards, but you want to get rid of the guards so that they don't get in the way as you present material to them. And I'll show you a couple of videos of that here in a minute. And so again, we have the two 6-inch wheels, which are used on the grinder. They're the most popular. They'll be your best friends in the building process. The difference between the two is this is a medium grit, where this is a fine grit. It's similar like grit in sandpaper. So this will remove more material. This is the 3MW7A6. It'll remove more material than the 3MW77S6. Those are our part numbers. 3M's part numbers work a little bit differently than that. So 3M calls it a cut and polish wheel, and it's a 7A medium. Now, the 7 is the density, so they take 7 inches of material and smash it down into being a 1-inch thick wheel. And then the A is for aluminum oxide material. That's what it's made out of. And medium is for the medium grit. So this wheel is a softer wheel, or a finer wheel, actually. So it's also a 6-inch and a density 7. So they smash it down from 7 inches to 1. And it's a S, silicon carbide maybe, and fine grit. So this one will remove, like if you use a bandsaw or a hacksaw and snips, they'll leave marks in the material. This one will remove those marks. It'll remove material. So you can also make a line on a piece and cut slightly away from the line, and then use this to get right down to the line if you're doing something extremely accurate. So this is removing material. This one, on the other hand, is a fine enough grit that it will just polish the tops of those bandsaw marks. So it'll make them shiny, but you'll still see the marks. So really the best setup is to have this on one side of the grinder and this on the other side. So you hit this first to roughly deburr it, get it down to size, take all the heavy burrs off from cutting, and then over to this one to finish it up. Now these wheels are very, very expensive. So some people only want to use the one wheel. This is the wheel that you want. If you only had this wheel, then you would have to file first those marks off and then come to this wheel to finish it up. With this one, if you only have this one, it leaves just very, very fine burr still left on it, and like one pass back and forth with a 3M pad will take that off. So if you're going to have one wheel, I recommend this one with some Scotch-Brite pads to take that off. And we'll talk more about the Scotch-Brite pads in a minute. So both of these 6-inch wheels come with reducer bushing. They both come with a 1-inch arbor. Almost no hobbyist is going to have a grinder with a 1-inch arbor. That's a high horsepower grinder. So 1/2 inch is by far the most popular size. We do have a 5/8 if by chance you have a strange buffer or grinder that has a 5/8 arbor. We see way less than 1% of those. So we send it with the 1/2 inch, but let us know if you have the 5/8. Okay, so next is the 2-inch wheel. This is good for like lightning holes especially. And you see that it says 7A medium on there, so cut and polish 7A medium. So it's the same density. It's still 7 inches smashed down to 1, still medium, still aluminum oxide. This is a 3/4 inch wide, deep, thick wheel, and 2 inches in diameter. And this uses a special mandrel that is a 3MM140, and it has a reverse thread on it, so the nut here works backwards how you would normally do it so that it stays tight when you're using it. And then it threads on here, and so the threads actually engage into the wheel. I can't do that without having a vise to put this in or pliers to hold it with or something. So, but just keep in mind the threads are backwards. So to screw it on, you're lefty-loosey in it. So this works good with this mandrel in drill press. That's the way I like to use it, because you can present your part to it and do the lightning holes. You can also use it in a handheld drill, but a drill gives you about the right surface speed. So a grinder, the diameter is large, so your speed's smaller. The 2-inch wheel, you're going to turn faster than you would on a grinder. So a drill press or a drill works well for that. And then the other size version is the 1-inch, and it's a 1-inch by 1 inch. It uses this mandrel, which just screws right into the wheel. It is also a 7A medium, so it's the same material on all 3 of these wheels. The other one is the 1-inch fine wheel. The only difference in this one, see, it has it's a 2 density, so they take 2 inches of material and squish it down into 1. So it's far less dense than the other wheels. In fact, you can maneuver it with your fingers. It's soft. So again, if I didn't mention it, these 1-inch wheels work best in a die grinder because they turn very fast, so you still get that surface speed that you need. And again, it just uses this 3MM100 screw-on mandrel to screw into the wheel and then chucks in your 1/4 inch die grinder. You can use this in the drill. It's just the surface speed's so slow in the drill that it just takes a long time to really do much work. When you're working with any of these wheels, you need to make sure you don't get the material so that it is in line with the wheel, because then when it wears in that one spot and cuts the wheel in half. So I have a picture of that here. Let me pull up. So there's an example of how not to do it with the sheet in line with the wheel, because it'll make a groove. And sometimes you make a groove anyway, and that groove's kind of handy to do some things with, but overall it wears your wheel out pretty quick. So when you use any of these wheels, you want to keep your material at an angle to it so that it's wearing evenly across the wheel. Now inevitably you will carve some kind of a notch in the wheel, and we do have a way to fix that. And it's not the way you would expect. We've tried wheel dressers, we've tried edges of files and stuff, and nothing seems to work. But use a piece of like 45, 30 grit, really aggressive sandpaper on a board, and then put the board up against the table and kind of raise it up slowly and present it to the wheel. So by doing that, you're obviously wearing down some of the surface of the wheel. You're making the wheel smaller, so you don't want to do that very often, but occasionally it's important to start over with the grooves that you're making in the wheel. And then one of the not common but occasional things that happens is when 3M makes this product, once in a while in whatever kind of goop that they make this out of, they'll get a spot that is more dense than the others. This kind of looks like one on the video, but it's not. But if you do end up with one that has a obviously dense spot, and the wheel will just shake like crazy and want to leave the table, or the grinder will want to leave the table. So if that's the case, that needs replaced. We try and catch those when we get them in, but once in a while those get through us and we need to replace them. Now generally, when they punch the center hole, it won't be quite in the middle. Maybe say a 1/16 of an inch off, and you'll get a little bit of a wobble, not the off-center density kind of problem, but just a generally off-centered. So if you take this and you put it in on your grinder and it's shaking more than you think it should, you can try that sandpaper technique and just bring it up to the bottom of the wheel slowly, so that it's just kissing it every time that the high side comes by. So it's going tick, 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 and just bring it up really slowly so that you're taking that high spot off and making it exactly round. Almost always you have to do that to true up a wheel when you start. This wheel, the softer wheel, I haven't really had to dress that often. I don't know if that's because I don't use it as aggressively as this. I just use it for, that light taking off after I do this. If I was only using this wheel, if I was starting out with a file and taking the big stuff off and only using this wheel, then maybe you would end up with grooves in it and have to dress it. Okay, so I guess the last thing is the hand pads. The hand pads are, oh, I'm sorry, I had one more. I had a couple old videos that I wanted to show on the wheel before we go on to the hand pads. So here's an example of the wheel on a bench grinder taking the saw marks out of a piece of extrusion. And then we have one on taking, let's see, just running an edge down. So this would be like you'd do with a normal skin. And presenting that top edge. Flip it over, present the bottom end, and then you would finish it with that other wheel or the Scotch-Brite. And then here is corner rounding on a sheet. So what you want to do is start with the long edge up and then bring the corner around from the bottom of the wheel. Whoop. So again, if you I'm going to use this as an example, but if you come up and you want to do a corner rounding and you present that corner to the top of the wheel, it's going to take the part and throw it right down to the floor. So if you come up here and bring it up this way, it does the corner, rounds the corner nicely without grabbing the edge. So now this is back to being a piece of Scotch-Brite hand pad. And you use this all over on the airplane. I would start out 5 to 10 of these, and you'll end up with a lot by the time you're done. You can use just regular scissors and cut them, and use them for different things. I'm gonna just cut it so that it fits this other piece we're gonna use in a minute. You can also just rip them, but cutting them obviously makes a nicer, cleaner edge. Grab a rib here. Okay, so one of the things that you can do with a small piece like this is you can actually take it and drag it through this area here that's really hard to get to in the inside areas of the substructure. It's hard to deburr that, but you can just kind of drag that through like that, and that'll deburr it. Also, when you go to prime, you'll want to scuff up every surface that you prime with the Scotch-Brite, and that gives a good adhesion surface for the primer. And then the last thing that you want to use them for is edge deburring. That maybe didn't come out right. It's not the last thing you want to use them for, but it's the last part of edge deburring. So you would run the part on your wheel to take most of the burr off, and then if you don't have the soft wheel, you would just real quick back and forth soften that edge with the hand pad. So hand pads are good for a lot of things. Also, if you're reaming holes, which is a different subject, but if you're reaming holes rather than drilling, you have very little burr on the inside of all your parts, and you'll find that you can just take the Scotch-Brite, run that back and forth, and that'll take all of the burr off of there without having to try and get a deburring tool in these tight places. So that leads us to the conclusion that, oh, I'm sorry, one more piece. Need a script. So this is the 3M M300 mandrel, and the way that works is you can lock a piece of Scotch-Brite hand pad in it, obviously put it in your drill, and then it spins like a flap wheel, so you can get inside of radiuses, like control stick tubes is what's coming to mind, that you can get in there and you can scratch up the inside, you can deburr the inside of a tube. But this stuff's flying around, so obviously whatever you put it up against is, excuse me, going to get hit. Okay, so I think that's it. So the reason that we carry 3M products, they are very much more expensive than their competitors. But we have found over the years, every competition product that we've tried, they just don't work as well. They don't function as well while you're using them, and they don't last as long. So you can get a wheel that's half the price, but it's gone in less than half the time, and you end up doing more work. With these wheels, you don't have to do much work. You're just lightly presenting the parts to them, and it's taking the the work out of it for you, I guess. I won't name any other brands, but any other brands we've tried to find cheaper solutions for us and for all the builders out there, but there's just nothing that really compares to the 3M Scotch-Brite products. So that's why we carry what we carry, and that's why they're as expensive as they are, that they really work well. And that's what we always choose, is tools that work better than anything else for the job, because good tools make it a pleasure to use. Thanks for watching, and check out some of our other videos.